Welcome back to Swell Academy. Spring break is over, so let's spring back into some knowledge. Here we're talking about law of sines, a great and useful tool for solving for missing sides and angles of a triangle when there isn't a right triangle present. But in reality, that is the whole magic behind the law of sines, is that there is a hidden right triangle present. And that hidden right triangle that we created, which is actually the height of the triangle, is what we could use to actually set up and prove and show you how the law of sines work. And the idea here is that if I look at sine of C, let's look at sine of C here, which is opposite over hypotenuse, right? So for your SOHCAHTOA is opposite over hypotenuse. Sine of C is actually height over my hypotenuse, which in this case is B, opposite the right angle, H over side B. And if I look at my sine of angle B here, same thing happens. My height is my opposite, and my side C is my hypotenuse. Now, if I took these two trig setups, let's say, and I multiplied both sides by their hypotenuses, or in this case, actually, this would have been B, I would have B times sine of C is equal to H, and I would have C times sine of B equal to H. And this, let's say, transitive setup where both are equal to H, I have both of these equal to H, is what allows us to set up one of our law of sine ratios, because in reality, B sine of C is equal to C sine of B. And if I want to algebraically set this up to look more so like the law of sines, I'd simply just need to move my B's and C's to be on the same side of each other, and you can do that by dividing both sides by sine of C. And we would get B is equal to C times sine of B over sine C. And then simply just getting this sine B to the other side, I could just multiply by 1 over sine B, both sides. These would cancel out. And this is where you get that B over sine B setup equal to C over sine. And the same goes for if you wanted to set it up to show the angle A and side A. So this is kind of how we go about setting up our law of sines, a little bit of way to prove how we're using the right triangle and whatnot. Now let's actually put this to use in a triangle that has an angle of 84 degrees for angle A, and let's just say 10 inches, we'll just say, for side A. This would be your little a in your law of sines. Now let's set this up. We're finding in this case, we're going to find an angle using a side. So we want to find angle using side. So what I need to see is, what do I have? Okay, you need to have at least 3 of the 4 pieces. So let's say in this case we want to solve for angle B. Well, then I would need a side for side B, or the side opposite angle B. I would need a side for that. In this case, let's say call it 7 inches. Now I can set up my A sine A, sine of angle A, I guess you could say, sine of B, and set up this ratio, this proportion, and work from there. And I would have this set up where A is 10, or 10 over sine of 84 is equal to 7 over sine of, In this case, the angle I do not know. And there's this cross multiplying setup. You have, now it's important first to get this, because we're going to have to use the inverse of sine. It's important to first get this 10 out of here, in which we would have sine B is equal to, I'm going to leave a little room just because you'll see the little setup I'll have set up here. 7, maybe I don't need to do that. 7 sine 84 over 10. Now, if I want to use the inverse, basically, it's hard to divide or calculate by dividing by sine. What you need to do is actually set it up where B is equal to the inverse, sine -1, of 7 sine 84 over 10. And this is how we get our angle B. Setting this up in our calculator, you could do this all once with TI-83, and you would end up with 44.1 degrees. If you're looking for the sine, on your calculator, hit your second button plus your sine button, and that will give you a sine -1. You could do this all at once using parentheses, or you could put it piece by piece, but this is finding an angle using a side, and we are finding a side using angle. And I'll kind of use the information we set up from the previous slide, because that's a lot of times what we have to do when we're working with this. We knew this was 7. We used trig to identify, let's just round and say this was 44 degrees. Now, if I'm subtracting that from 180, and I'm taking the 84 and the 44 away from 180, well, then I'd be left with 52 degrees here. And now this is important because if I'm looking for C, remember you need 3 out of the 4 parts. This angle here, 52, gives me my third part. And I can go back and set up 10, which is A, over sine of 84 is equal to, we don't know what C is, or the side of C, but we do know its angle using the previous slide is 52 degrees. And you go back to your cross multiplication here, one multiplied to the other, C sine of 84 equal to 10 sine of 52. Now this is a little bit easier. We're not required to use a inverse. You can divide by the entire sine of 84 and get a result where C is equal to about 7.92 by putting this all at once or piece by piece into your calculator. So great setup using a right triangle in a triangle without a right angle to set up certain ratios using a law of sines, using our trig. And actually, as long as we have 3 pieces, whether it be 2 angles and a side, or 2 sides and an angle, you can find each and every piece of a triangle, whether using trig or solving for pieces and doing subtraction when using angles and whatnot. This is all good to understand, better to practice. The more you fail, the more you succeed, so keep working hard.